Transforming quadratics. So, what happens when we do each of the following to f of x? That's what we're looking at. We take a function, we can move it by adding, subtracting outside the function, adding, subtracting inside the function, or multiplying it. There are other things we can do, but these are the ones we're going to look at for today. So, think of f of x as the y coordinate. So, if we take the y coordinate and add 1 to it, this is increase each y coordinate by 1. So the y coordinates going up by 1 means that it's being shifted up. This will be a shift up. Same thing, if we're doing that, then this will be a shift down. When you see this with graphs, okay, here's the original, y equals x squared. The plus 4 outside the square adds 4 to it. We shifted it up 4. The minus 2 shifted it down 2. Now, for f of x plus 1, what this is saying is we're going to take f of x, but now the new input is going to be x. So we're going to take what new number do we add to 1 to get the old number? Well, if I take negative 1 plus 1, that'll add to 0. So I would plug in negative 1 to get out 0. And then 0 would be plugged into the function to get f of 0. So what this is saying is negative 1 will now have the output that 0 used to have. And that's a little difficult to wrap your head around. But it's very straightforward when you graph it, that the inputs are now one left of where they were. Which is weird, because usually we think of adding as moving it to the right. And now it's going to be one right when we subtract. So here's x squared. If we do x plus 4 squared, that moves it actually to the left 4. So if you do this inside, it's subtracting, meaning going left 4. And here we look at minus 2 is 2 in the positive direction to the right. Anything inside the parentheses goes the opposite direction of what you expect. So minus 2 is going to the right, plus 4 is going to the left. Now remember that f of x is the y coordinate, so we're going to multiply each y coordinate by 3, which means that a y coordinate that used to be here will now be multiplied by 3. And a y coordinate that used to be here will now be way up there. So what this ends up doing is it expands. But the numbers that started at 0 don't expand at all. So they're expanding away from the x-axis. Now if you take the same thing and we multiply it by a negative, if I take this, multiply it by a negative, it ends up on the other side because positive turns into negative. If I have something like this, that turns into a bigger negative number, And what happens is it also reflects. So here is the red graph is x squared. And the blue graph is 3x squared, where I multiplied each coordinate by 3. So this 1 turned into now 3, this 1 turned into 3. It looks like it got thinner, but really what it did is it got taller. Even though there's no top, this point is not from this one coming left, it's from this point going up. Same thing for the green one. It ended up going down because that negative causes it to reflect over the x-axis. So the summary of all of this is that if we add or subtract, it's a translation, a slide. And that slide, if it's outside, it will be up or down. If it's inside, it'll be left or right. But most importantly, notice that adding inside moves it left and subtracting inside moves it right. Not what you expect for left and right. It is what you expect for up and down. For reflection, you get reflection across the x-axis if you take this and make it negative. And then if you multiply it by some positive number, if you multiply it by a number bigger than 1, it'll stretch it away. If you multiply it by a fraction, this says 1/3 if you can't read it. If you multiply it by a fraction, it gets closer to the axis. That's how we transform quadratics.